Welcome back to my channel. This is Lekana. Today I'm here with the topic that is called insertion sort. In this video, we're gonna discuss what is insertion sort, algorithm for the insertion sort, working principle, advantages, disadvantages, and applications of insertion sort. Insertion sort, it is a simple sorting algorithm that works by building a sorted array one element at a time. It is efficient for small data sets and is often used as a base case for more complex sorting algorithms. In this image, you can see the step-by-step explanation how an array can be sorted. First, we'll take one array which is in the sorted form. Example is 5, 2, 4, 6, 1. You can see it's not in order. It is unsorted array. The first step is first we will take the first element of an array as a, we'll assume it as a sorted one and select the first element. Select the first element 5 as the sorted portion. As I said, the first element of an array is assumed as a sorted portion. We'll start this third step. It says that second element will compare with the first element which is considered as a sorted portion. If the second element is less than the first element, then swapping will take place. This process will continue until the array becomes sorted one. Next, we have the insertion sort algorithm. Insertion sort, as I said, it's a simple sorting algorithm that works by building a sorted array one element at a time. It is considered as in-place sorting algorithm, means it doesn't require any additional memory space beyond the original array. What is the algorithm for this insertion sort is, as I said the step by step how we do the sorting for an array. First, we have to start with the second element of an array, as the first element in the array is assumed to be sorted. Compare the second element with the first element and check. If the second element is smaller, then swap them. Move to the third element and compare it with the second element. Then the first element and swap as necessary to put it in the current position among the first three elements. As I said in the step by step how we do, we'll compare the third element with the first and second element. If it is small, we'll swap. If one is small and one is large, we'll place it in the middle of those two. Continue this process. Compare each element with the ones before it and swap as swapping as needed to replace it in the current position among the sorted element. Repeat until the entire array is sorted. You can see the working of the insertion sort algorithm. See, here we have an example. We took an example of an array which is 23, 1, 10, 5, 1, 5, 2. As I said in the steps for how to do this algorithm sorting, first we'll take this 23 as a sorted array. Sorted portion. Current element is 23. The first element in the array is assumed as a sorted one. This is the 0th index 1, 2, 3, 4. Total n is 1, 2, 3, 4, 5. N is 5, but index will be n minus 1. It will be 4. It will begin from 0 to 5. This is the 0th index 1, 2, 3, 4. Now 23 is the sorted portion. We don't change anything. Now it will begin with the second element. 1 will compare with the 23. Yes, 1 is less than 23. Now swapping takes place. Now 21, it will become 1, 23, 10, 5, 2. Next iteration, it will begins with the third element, that is 10. 10 will compare with the 23 and 1. 10 is less than 23, but 10 is greater than 1. So 10 will be placed in between of 1 and 23. You can see 1, 10, 23. Next 5. This is the fourth element. It will compare with the third, second and first elements. 5 is less than 23. 5 is less than 10, but 5 is greater than 1. So 5 will be placed in between of 1 and 10. You can see the result. And last we have 2. 2 will compare with 23, 10, 5 and 1. And 2 is greater than 1 and it is less than 5. It will be placed in between of 1 and 5. These are the steps what I have said now. And at last we'll get the sorted array as 1, 2, 5, 10, 23. The logic behind this insertion sort is, here we have first for loop. We'll take a for loop. I will begin from 1. Why it will begin from 1 is, as I said, this is the 0th index. We consider this the first element as a sorted portion. So we'll compare from the second element, that the index of this second element is 1. So it begins with I equals to 1 till I is less than n and I is incremented. This key equals to array of I. What does this means is, array of I is nothing but, in this example we can take 1, this 1 as a array of I, which will be stored in the key value. We can call it as a temp value also. It will be stored in the key value, and j will be I minus 1 because I will be 0th index. So j will be equals to I minus 1, j will be 0th index. So here I is 1, j will be I minus 1 means 1 minus 1, it is j will be 0. Next, while loop we have j should be greater than or equals to 0, because we'll compare I with the until the 0th position. For example, if it is in the 3rd position, we'll compare second, 1 and 0. We won't go to the negative value. So j should be greater than or equals to 0, and array of j will be greater than or key. Now in this example, array of j is 23 and the key value is 1. Array of j 23 is greater. Yes, it is true. If it is, the statement is true, then array of j plus 1 will be equals to array of j. Now it will be, you have seen here, now array of j plus 1 will be equals to array of j plus 1 will be equals to array of j. You can see it has swapped. And next we have j equals to j minus 1. Now the condition will become false. J will be 1. Now j will becomes 1, 1 minus j will be 0, and 0 minus 1 will become minus 1. Now if you go into the loop, it will become false. So it will come out then, but we don't have the minus value. So the array of j plus 1 will be equals to the key value. This is the logic behind the insertion sort. Next we have the time complexity analysis. We have best case, average case and worst case. In the best case, the time complexity of the insertion sort is big O of n when the array is already sorted. In the worst case, big O of n square when the array is in the reverse order. In the average case, big O of n square, as the algorithm reads to compare each element with the sorted portion. Next we have the advantages and disadvantages of insertion sort. In the advantage, we have it is simple to implement and efficient for small data sets and stable. Preserves the relative order of equal elements. The disadvantages is it won't applicable for the large data sets, as it has a quadratic time complexity and not suitable for data that cannot be fit in the memory. And next we have how this insertion sort can be compared with the other sorting algorithms. We have the sorting algorithms, others are bubble sort, we have quick sort, merge sort. In the bubble sort, insertion sort is generally more effective than the bubble sort, especially for the nearly sorted arrays. In the quick sort, it is usually faster than the insertion sort for large data sets, but insertion sort may be preferred for smaller array. The merge sort has a better time complexity, big of n log n, compared to the insertion sort, making it more suitable for large data sets. Next, what are the applications of the insertion sort? We have the real world application, that is data sorting, incremental sorting, educational purposes. How does this works in the data sorting is, insertion sort is used oftenly to sort small data sets such as data in a personal context or calendar events. In incremental sorting, insertion sort is efficient when new elements are continuously added to a partial sorted list such as musical playlists. In educational purpose, insertion sort is a commonly taught algorithm in computer science courses due to its complexity and utility nature. Thank you for watching my video. Thank